Hello everybody. In this video we'll be going over one of the sections in chapter 6 of our text entitled Chemical Composition. In this video we're going to cover how to convert between mass and atoms and mass. We've already seen how to go from mass to moles and moles to atoms and atoms to moles and moles to mass, and we're going to see how we can combine those types of problems together to interconvert between these two quantities. So our first question is here: how many aluminum atoms are in a can that weighs 16.2 grams? So in this case we're given a mass of aluminum and we're asked to find how many atoms there is. Our solution map here is going to look different, and it's very key for you to understand these problems that whenever you're being asked to go from mass to atoms or atoms to mass, you have to go through the moles. Okay, you either have to convert the mass to moles and then to atoms, or the atoms to moles and then to mass. Okay, students often try and figure out some kind of little shortcut or something for this, and there really isn't one at all. This is a two-step problem. So because we have two steps, we need to have two facts that we're going to be working with. We know that there's for every 1 mole of aluminum, it weighs 26.98 grams. We got this again from our periodic table. This is its atomic mass. And we know that 1 mole is going to equal 6.022 times 10 to the 23rd things, in this case, atoms. From these, we'll have two conversion factors. To convert from grams to moles, we put the moles in the numerator, the grams in the denominator. To convert from moles to atoms, we put the atoms in the numerator and the moles in the denominator. When we put them all together, it looks like this. We start off with the mass that we had in our problem, 16.2 grams of aluminum. We multiply by 1 mole of aluminum for every 26.98 grams of aluminum, canceling our grams of aluminum. And then we multiply by 6.02 grams of atoms for every 1 mole. That will cancel our moles. What we're left with is our atoms of aluminum, which is 3.62 times 10 to the 23rd atoms of aluminum. If we do our little check, we know that 26 grams is 1 mole of aluminum. We had less than that. We only had 16 grams. So we know that we should have gotten less than the number of atoms that are in a mole of aluminum. And we do, in fact, have that. Okay. We have fewer atoms than 1 mole of aluminum. Let's see if we can go the other way. If we're asked, if we're given the number of atoms of copper and we're asked for the mass of that much, can we do those problems? So this time we're given that we have 2.94 times 10 to the 22 atoms of copper. We're asked to find the mass of copper. For our solution map, we have atoms of copper to moles of copper to grams of copper. Okay, so it's basically the reverse of the situation we had before. But again, our gateway between atoms and grams is going to be moles. We go and look up our relationships. We go to the periodic table and find out that 1 mole of copper is 63.55 grams. And we know that 1 mole is 6.022 times 10 to the 23rd things. And we place in our conversion factors. Again, paying attention to the units and what we put in the denominator versus the numerator. When we put it all together here, we have the given amount. We have our atoms in the denominator, canceling those. And we have our moles in the numerator here, denominator here. Those are going to cancel. And we wind up with our grams in the end. And we see that it is 3.10 grams of copper. We were limited by the number of sig figs in this number. And when we do our little check here, we see that we were given a number of atoms that was less than 1 mole, and therefore we should have gotten a mass that was less than 1 mole of copper, and we in fact did.